This is testing the laser cutting 8mm pine. Here are a few more interesting examples of work with the laser, both cutting and engraving. So, this is my home-built 60-watt water-cooled CO2 laser cutter. It has a bed approximately A2 in size, which can rise and fall about 170mm. The movement of the laser is controlled by gerbil software loaded on an Arduino Uno. Instructions telling the machine what and where to cut, written in G-code, the language of CNC machines, is sent to the Uno from a Raspberry Pi running BCNC software. I generally do my designing on a PC in our office, where I also generate the G-code. From there I can send it to the laser cutter in my workshop over Wi-Fi. The laser cutter is protected in a polycarbonate case, which allows a clear view of what's going on but keeps the infrared safely inside. The top and the sides of the case come apart easily to give access to the works. The machine sits on a base on casters with a lower shelf which supports the air assist pump, the water cooling system and the extraction system. There's a control panel with a master stop button, buttons to enable the motors and the laser, a laser power analog control, an LCD panel which monitors the cooling system, a switch to raise and lower the bed amongst a number of less used controls. I've tried to make as much as I can from scratch of basic general purpose components. That includes most things apart from the laser itself, the high voltage power supply and the laser focusing lens. I began the project with a number of basic bits that could get a gantry moving on a frame. These included stepper motors, Pololu motor drivers, an Arduino Uno, CNC shield to link the drivers to the Uno, and some V-channel extrusions and Del rim wheels to run in the channels. It's the development and availability of these parts which has enabled precision computer-controlled CNC machines to be made by amateurs like me. Having made up a frame and gantry, I was able to get the stepper motors fitted with tooth wheels to move things around using tooth belts meshing with the wheels. The next stage was to add more framing and more electronics, which I won't go into here, but which is covered in detail on my website. Next I made the bed, which is supported on 4 screwed rods driven by 4 more stepper motors, so it can rise and fall as required. The laser cutter needs 3 mirrors to direct the beam onto the work. I made these out of pieces of 25mm diameter copper bar. I sanded them flat with increasingly fine wet and dry, and finally polished them with Solvol Autosol. I was slightly surprised to find that they work quite well. The mirrors need various mounts to fit them on the machine. These, like most aspects of this project, I designed as I went along, so they can look clumsy and a bit fiddly. In the unlikely event that I make a Mark II version, all these little details might be a bit more elegant. This part includes the third mirror and the lens which focuses the beam onto the work and which moves from left to right on the machine. Here you can see it mounted in position. This is the base built from MDF and steel interclamp fittings. Eventually the laser arrived. I made a cradle to hold it. I've temporarily fitted a laser level which I use for initial alignment of the mirrors. Here the cradle is more or less in position. I mounted it at an angle which I thought would save space. However, it does make it more tricky to align. On the plus side, it probably does help to clear air bubbles in the cooling water. The electronics get installed on a panel and the whole thing is gradually wired up. The electronics could be rationalised, but as I said, I was rather designing this as I went along. Also, the Raspberry Pi monitor and keyboard get installed using more interclamp fittings largely. Everything bar the case is more or less finished, and I could do some initial testing, operating remotely over VNC to be safe. So lastly, I made the case from polycarbonate and aluminium angle. Here the polycarbonate bits are complete. It just needs sheet aluminium around the electronics. Like this. That's more or less the end of this video, but remember, you can see a lot more detail on my website, including circuit diagrams and software and where to get parts. Thanks for watching.